72%, the vast majority of inspections we conduct have major or critical issues that are likely to cause downtime. That's huge. Critical issues that cause downtime, way more common in operating assets than new construction. But issues that you see in new construction can also progress and become more severe over time. So the problems that are minor and negligible early in a project's lifetime are just a starting point. Fixing them early on, when they're likely easier to address, things really got interesting when we started to look for a common thread to connect the projects that had problems. So as you can see here, there was one EPC that they worked with that had a much higher number of average issues per project than the others. We also saw issues at projects built by this EPC that simply weren't found at other sites. The wrong equipment was installed. That wasn't.
You're flashing. All right, welcome everybody to our webinar. This is episode 1 in a best practices series. This webinar will be talking about and looking through the lens of reducing solar project downtime before and after commissioning. All right, let's jump into it. The webinar is going to have our normal structure, so it'll be 45 minutes of active speakers and then 15 minutes of Q&A. So the speaking time will be around 20 minutes for myself and then 20 minutes for Tori. As always, if you think of any questions during any of the presentation, feel free to throw them in chat, and we will get to them at the end of the presentation, but throw them in there else you'll forget, and it's always good for us to read them as we go. So let me introduce Tori Clifford. She is the head of growth at HelioVolta, which is a technical advisory firm. They have developed a software called SolarGrade, which Tori will be going into more detail about. But it's a field operations and asset management software that is currently being used for over 20 gigawatts of assets. So a very impressive piece of software, and I think we're all looking forward to hearing more about it. As for myself, I'm Rylan Gordon. I'm the technical director for the United States of Sinovoltaics. I have a background working with EPC contractors, building projects all over the Southeast. And now I do technical due diligence, ESG, traceability, and other de-risking things on behalf of Sinovoltaics. But it's nice because this case study kind of reviews a culmination between my EPC life and my current role. So we'll jump right into the case study now, and then this process will be chronological. So next will be, hey Fernando, next will be we'll go chronologically through the process. So we'll start at manufacturing, we'll work our way through the panels being produced and then shipped to site. And at that point, Tori will take over and speak more about her software. So before we begin, I will give a quick update for those who are not familiar with what Sinovoltaics does, why we think it's important, and then where and how we do it. So Sinovoltaics is a technical due diligence company, which is fancy speak for we are the eyes and ears for people who are buying renewable energy assets as they're being manufactured to make sure that they're being produced to the highest quality possible. So we go to a manufacturing plant that is producing your equipment. We have reviewed your contract, we know what it stipulates, and we make sure that those pieces of equipment are satisfied under that contract. We also do traceability and ESG, which again is part of our initiative to de-risk solar and energy storage. For traceability and ESG, it's obviously very close to our heart in the United States as the guidance and regulations shift constantly. But what this is making sure that you know exactly where your equipment is coming from, you know how it's being produced, where it's being produced, you know where the materials are coming from, and you have documents to prove it. So you will have no issues coming into the US Customs or anything along those lines. You'll have full understanding and transparency into how and where your equipment was being manufactured, as well as its quality. I've touched on this a little bit, but what Sinovoltaics expertise is solar and energy storage. So we cover any components that are used in these projects. So that's solar modules, that's inverters, anything in balance of system, transformers, all the way down to racking and cabling. So we do all of it. And we have specific softwares and processes in place for each one. So each one is a tailored service specific for that piece of equipment. We've been recognized plenty of times, and we hold many certificates showing that we produce very high quality and very unbiased, impartial opinions about how manufacturers operate. So that's always good to be recognized. Lastly, for the background, Sinovoltaics likes to not only implement quality control and management systems, but we also like to innovate how those systems, how that process is conducted. So for example, for solar, we've created SELMA, which is 100% EL, which is electroluminescence testing, which can run in real time as modules are being produced. And it will pull out defects that it finds throughout that production, which allows the Sinovoltaics team to remove those defects in real time without delays for solar shipments. It is a industry-leading piece of software and extremely important. And the reason that we have the data and insights into these manufacturing processes, which allow us to do these sort of case studies. So it's incredibly powerful, incredibly useful, and I'll speak more about that as in the coming slides. So for this specific case study, we are looking at defects that were caught during the manufacturing process. So there are many defects that can be caught. Selma identifies the type and the severity of these defects in real time. You can see in these images that Selma is identifying, it almost looks like targeting software, these defects of individual modules and their severity. Selma also incorporates the contract that is active as these materials are being purchased. So it identifies against the contract these defects. So these are actionable events that can be removed in real time. Selma identifies 15 different defects, as I said, but for the purpose of this case study, we will only be speaking about one of them, which is the solder fault, which I'm sure many of you are familiar with, as it is a huge nuisance and has caused a lot of problems. So we will be focusing specifically on the solder fault and ignoring all the other defects, even though we did catch quite a few others. So what is a solder fault? A solder fault is any time that the soldering material is misplaced on the cell of a solar module. So you can see in each of these images, the color image at the top shows the soldering slightly being misaligned from where it's supposed to be, which looks like a small defect and may or may not have a huge impact. But in other scenarios, there can be too little soldering material or too much, which in some cases can lead to overheating as the wire exceeds its capacity for how much it can take before it warms up. And then in the bottom, you can see that this is an image from Selma, the software, showing what a solder fault looks like through electroluminescent imaging. And you can see that it looks like a dark spot, as oftentimes a solder fault will cause a short circuit, which will cut off production from whatever sequestered piece of material is no longer connected due to that solder fault. So multiple different issues, multiple different severities. Like I said, you can have different scenarios that are caused from the solder fault itself. One, which is very, very common, is the solder fault, like a shaded cell, will cut off the current from a specific block of cells, which will activate a bypass diode, and you will lose 1/3 production from that module, which is no big deal by itself. But as these start to stack up, then as we'll see, there is a bigger effect that can be caused. And on the higher severity side, you can see that often, oh, no audio. I'm seeing some chats that we're getting no audio. So if anyone else is having that issue, please put it in the chat. Otherwise, I'll keep going, and we'll deal with that. Okay, perfect. Lovely, lovely, lovely. Thank you, thank you, thank you. Very responsive chat. This is lovely. Thank you, guys. Okay, so in a more severe case, we can see that these solder faults can cause miniature thermal events. And I'm not going to stick on this topic too much because we all understand how serious these little thermal events and overheating hotspots can be on a solar cell. Obviously, that's not an argument anyone would argue against. So that's on the severe side. For this case study, we're going to examine the more conservative case where a solar module or a solar cell is deactivated due to a short circuit from these solder faults. So they're stringed together, a bypass diode is activated, and some of the cells are deactivated due to that fault. For this case, we did run SELMA on the entire portfolio, which was 31,774 individual modules. In those, we found through SELMA, the 100% analysis with EL, that there was 1,621 defects in the batch, which is 5%. This is pretty normal numbers for us. We usually see, 5%. If it goes higher, there's maybe a bigger issue, but this is a pretty normal sample size. And to reiterate, this is a tier 1 manufacturer that we are pulling these modules from. And also this developer was also very experienced, probably why they hired us, but both parties were very experienced, and yet there were still 5% defects. In those defects, we found 324 of them were solder faults, which is around 20%. So that is what this case study was based off of. We mathematically simulated where these defects would be scattered throughout the solar array. For this, we assumed strings of 28. There would be 1,141 strings going to 285 inverters. And we randomly generated where these defects would be found throughout the throughout the strings. Zeros represent solar modules and ones represent where defects would be found. Randomly generated, then we did an analysis of how these defects would affect the overall project. And towards that, we looked at the wattage loss for a bypass diode being activated. And then when multiple bypass diodes were activated, we looked at the voltage drop, which in some scenarios can turn off an inverter if the voltage drops below a minimum requirement. So there can be cascading effects that shut off entire strings simply because the multiple defects were found in a same string. And this can very often happen when sorry, we're getting some no slides. We're getting some, okay, I think we're good. This can be caused because one machine can be uncalibrated during manufacturing of these solar panels. And you can have a serial defect of loose solders, which would easily take down an entire string, cause hotspots and other issues. So this is not an unlikely scenario. In our analytics, we found that between 0 and 4 defects were found on each string. 197 strings were affected, and the loss solely due to these solder faults was around 590 kilowatts, which this project as a whole was 15 megawatts, so not a small impact. And yeah, as I mentioned earlier, when you have multiple of these solder faults in the same string, you can have this stacking effect where the voltage drops to a certain minimum, a string goes down, and the annoying part is the EPC or whoever is managing the site will not have any transparency. They will not know this is a solder fault issue, so they will be looking at IV curves and other issues to try and identify these losses while the wattage is being lost due to these issues that could have been caught ahead of time. So I'm sure everyone here has experience working in the field, looking at these looking at these solar arrays. A string goes down or a panel is not producing as it should. And it's really, really hard to diagnose what's going on in real time to save these production losses from happening. Or there are other scenarios where you are testing your array for a utility and you need to show that you have capacity of 97% or whatever that number is to make sure your interconnection is accepted. And having issues like solder faults, turning off your strings, will cause incredible delays and embarrassments in those moments that is better off avoided. So if there's a simple solution to avoid these issues, then why not take it? So I believe this illustrates the point that there are small defects that are going to be found in every single batch of solar panels being produced, no matter if it's a tier 1 manufacturer or a manufacturer that's just getting started. There will be defects in these modules, and you will have no transparency into what these defects do, how they affect your solar asset, until they've started to erode your profit, or delay your shipments, or you have to call in crews to replace individual modules all over your site and you have no idea why. When you could just deploy a piece of software with a trusted advisor that in depth gives you a review of every single module being produced, finds your issues in real time, causes no delays, and removes those defects from ever being a headache and ever being considered as an issue. It seems like a no-brainer. So we've gotten to the part where these solar panels have been deployed to site, and they are ready to have more analysis done on them. So I will let Tori from HelioVolta take it from here to talk about her asset management tool and tell you more about that. Tori, you ready?
Yep. I think I'm just getting my video turned on. Can you see me?
I cannot see you yet, but I'm waiting with anticipation.
All right. Well, it looks like that video might be just taking a little time, so I'll go ahead and get started. And first, thanks so much, Rylan, for a great presentation. I remember when any kind of production line monitoring or oversight was a big deal. So 100% independent EL in the factory is just a massive step forward. And with that said, let's turn to exploring the causes of downtime and prevention tactics through the lens of field data collected by HelioVolta. And before I really dig in, I want to give you a little bit of context. So the data that I'm about to present comes from field inspections conducted with SolarGrade. That's a software platform, and it's what you see on the right side of the screen. So this is a desktop and mobile app that supports common PV and energy storage site visits from that initial site survey all the way through construction and operations. The software is developed by HelioVolta, and that's the company that I work for. But we don't just develop software. We also have a technical advisory and field inspection arm of our business. So our team of field engineers uses SolarGrade for every site visit they conduct. And that's just what our CEO and co-founder, David Penalva, is doing on the left side of your screen. So that's our fearless leader. He's on a rooftop site. He's using the SolarGrade mobile app to document and geotag an issue that he observed. So first, let's do a quick rundown of what to expect from me over the next 15, 20 minutes or so. I'm going to give you a quick intro to HelioVolta's inspection data set and some of the top line findings from all of our inspections. Then I'm going to jump into some specific examples from the field that highlight best practices for preventing downtime. So as promised, here are just a couple of important points on the data set that we're going to discuss today. When our team goes to the field, they're usually looking for issues and nonconformities that might do something to impact the safety, reliability, or performance of the asset. So keep in mind that this data is coming from direct observations on the roof and on the ground. It's not SCADA data. It's not inverter alarms. So it's coming from hundreds of inspections conducted from 2021 through 2024. You can see a nice little point on that map for each one. About 3/4 of the projects are rooftop, 20% are ground mounts, and then carports are going to fill out the balance. There are 3 main types of inspection. We do QA/QC for new construction. That includes milestones like Golden Row, substantial completion and commissioning, as well as inspections on operating assets. And that's going to include like your typical health audits, as well as inspections right before the end of the EPC warranty period. And then finally, we use SolarGrade for inspections that respond to specific events, like failure root cause analysis and remediation oversight. So before we get too far along, let's define some terms, make sure we're all speaking the same language here. So every issue that our team observes in the field gets a rating for risk severity that starts at negligible, goes all the way to critical. So this rating correlates directly with downtime. With critical issues, the risk of a safety event is so high that partial or total de-energization is required before our engineer even leaves the site, and it stays de-energized until that remediation is complete. Major issues require urgent remediation and are also likely to cause downtime, but it's not as immediate. And as you can see in the chart on the right, critical issues are found more frequently in operating assets, while major issues are slightly more common in new construction. And this makes intuitive sense, right? If a system is under construction and it's not yet energized, downtime really isn't a factor. All right, so another thing to keep in mind is that the same general type of issue can actually present at different risk severities in the field. So let's use the example of improperly torqued connectors here. So kind of on the bottom part of this slide, you can see under negligible, there's an isolated instance of an over-torqued connector with signs of improper tooling. So there are excessive marks on the back nut. That indicates pliers were probably used to tighten that back nut, not a proper torque wrench. When this issue is minor, we see in that second example, 2 isolated instances of under-torqued back nuts on field-made home runs, but there aren't any other workmanship or thermal issues in either of these projects. Now, to be clear, I think these 2 issues matter. It's possible the integrity of these connectors has been compromised. There could be moisture ingress. This could cause overheating. There might be an electrical fault. You know, it's a problem, but it's not an imminent threat. There aren't any thermal anomalies. We just need to keep our eyes on these connectors over time until it makes sense to fix them. But things start to change as we move to the right. So in that major example, there's a field-made home run where the connector is cross-mated and it's under-torqued, and this is a systemic issue on site. This means there's a lot more opportunities for failure and a much higher risk of thermal anomalies as these connectors operate over time. This is a problem that should be addressed ASAP because there's just too many potential failure points to simply monitor. When we get into the critical issue, there's an under-torqued back nut on the field-made home run that is catastrophically damaged. You can see that it is charred and it is melting. Additionally, there were under-torqued back nuts systemic on this site. There were multiple instances of overheating connectors. So in other words, the catastrophic failure event has already happened. There are more that are possible, and they are imminently possible. So it's time to shut down. So there you have it. Improperly torqued connectors, 4 different flavors of risk severity, and they have varying implications for downtime. So where do these ratings come from? Well, our team walks through a matrix of questions to assign that rating objectively in the field. And if you want to know more about it, we actually have the whole matrix on our website. Okay, so now that we have our terms defined, let's step back and let's think about what we see across our entire data set. First, 72%, the vast majority of inspections we conduct have major or critical issues that are likely to cause downtime. That's huge. That makes me angry. 11% of inspections lead to partial or total system de-energization before our team even leaves the site. Again, much more common in operating assets. But thinking more broadly, we see more issues related to wiring and connectors than any other type of equipment. And in my book, that's actually pretty good news, because issues with connectors and wiring are addressable with training and education. Based on our inspection data, the bulk of issues that lead to downtime are not big ticket items like PV modules, where things get extremely costly fast. Now, I don't want to make light of the hassle and costs that rewiring a project might entail, but replacing all the modules in the project is simply on a different level. So if there's one takeaway I hope everyone here leaves with, it's that giving your crews more training on wire management, wire terminations, and connector installation is almost always a good idea. All right, and I'm going to take a quick pause to go off the stage and come back on, see if that fixes this video issue.
Lovely. Thank you, Tori.
Sorry, Rylan, how do I leave the stage?
No, you're good. If you look at the bottom of the screen, you'll see that arrow with a... Oh, perfect. There it is. Quick learner. Always knew it. Yeah, it's just not quite the same webinar without Tori's face. All right.
Right. Background is going to be gone, but I'm still here.
Fantastic. Nope, I can hear and see you.
Okay, beautiful. Let's
All right, I think it's a game on. All right, round two.
Awesome. Okay, well, let's dig a little deeper on those critical issues that always cause downtime now. So nearly 70% of them, and that's the top 4 issues that you see highlighted on the top of the screen, are directly related to thermal anomalies. So when equipment temperatures are high, there's a risk of a thermal vent or fire, and there is no incident with higher potential for downtime, lost revenue, reputational harm, and most importantly, safety risks than a fire. So de-energizing the system and sacrificing some energy yield is clearly worthwhile to avoid a catastrophic failure scenario. We see these thermal issues most frequently in the DC distribution components of PV systems. And that's what you see in the pie chart on the right. And again, think wiring, think connectors when you're thinking about the culprits here. Now let's look a little bit more closely at the most common issues overall in those new construction inspections versus operating asset inspections, and at every level of risk severity. And as you can see, there's a fair bit of overlap. So issues with improper connectors, wire management, and wire terminations appear on both lists, as do issues with labeling and hardware. So hotspots, which rank as the 6th most common issue overall in operating assets, don't even make the top 10 for new construction. We know, based on our data set, that thermal issues are the top cause of downtime. Nothing temperature related even hits the list for new construction. So does this mean your hands are tied? There's nothing you can do to prevent downtime before a site achieves commercial operations?
Tori, it looks like we lost you again. I feel like this highlights our point about technical defects in real time. So this is, I don't know if this is a...
You know, maybe we need new webinar software too, not just field operations software.
We'll work on it. We'll work on it. Add it to the list. All right.
All right. But anyway, there's obviously things that you can definitely do to prevent downtime before you hit COD. So let's zero in on those top 10 issues in new construction inspections with that downtime prevention in mind. First, as we noted just a few minutes ago, critical issues that cause downtime, way more common in operating assets than new construction. But issues that you see in new construction can also progress and become more severe over time. So the problems that are minor and negligible early in a project's lifetime are just a starting point. Fixing them early on, when they're likely easier to address, is the way to avoid downtime later. So something as simple as proper labeling means servicing equipment is going to be a lot faster and a lot more safe for your technicians. Addressing missing and improper duct seals, means equipment is not exposed to water and debris that accelerates degradation and can trigger premature reliability failures. Tightening up those loose wire terminations makes hotspots and arc faults far less likely down the road. And that is going to bring us to our first best practice: monitor and track issues through construction and handoff and beyond. Don't let them become critical. So even if you can't remediate every minor and negligible issue right away, you don't want to lose track of them. So our software, SolarGrade, ensures that nothing falls through the cracks. It's georeferencing every issue your team observes in the cloud. You know it's there, and the next time someone goes to site, you can have them check on it. It gives you space to take corrective action when doing so makes sense for your budget and for your schedule, and before the issue causes downtime. So now let's go into a few more specific examples from the field. First, we're going to look at a case study from a CNI developer and asset owner that contracted HelioVolta. Sorry, the screen disappeared for a second, but I think everyone can still see me. Okay, so this client contracted HelioVolta to conduct construction QA/QC inspections and a few health audits on operating assets. The client supports a lot of schools and local governments, so they take quality and safety very seriously, but they also sub out 100% of their EPC work. And our inspections for this client really prove the value of QA/QC at key milestones. Across our full data set, critical issues are found in 11% of HelioVolta inspections. If you just look at new construction inspections, that rate is 8%. But for this client, who takes pains to clearly communicate their requirements to their subcontractors, who generates punch lists from every single milestone inspection, their rate of critical issues is just 2%. So simply bringing in a third party to conduct that robust QA/QC, to clearly communicate your standards, and to diligently track punch list completion is going to mean fewer critical issues, less downtime for your project. So now let's shift gears, look at some operating asset inspections. For this client, we conducted 30 health audits on operating assets that were randomly selected from 2 different portfolios. And when we dug into the data, inverters jumped out as the PV system component that generated the most issues, including nearly 100 critical and major issues. So again, critical and major, think downtime. So first, we looked at the issues by OEM, and we saw that 2 of their suppliers had significantly more issues per project than the others, and that one of those problem suppliers was deployed to 65% of the projects across both of the portfolios we inspected. So we really drilled into the issues in inverters from this manufacturer, and here you can see the results from that dominant supplier. So critical and major hotspots, water ingress, and corrosion issues emerged as one of the major causes of concern and drivers of downtime. It led our client to take immediate action with an inverter wire termination retorquing campaign that included training for all of their technicians. So what's our key takeaway here? Well, it's really not enough to look at inverter alarms and error codes to evaluate OEMs or set O&M schedules. You should look at the granular data from the field for each piece of equipment. You should analyze all of the observations that your team makes inside each enclosure at scale. And I would say this is just as important to preventing downtime as analyzing your production data. So let's move now into crew performance. So for this client, we conducted 80 inspections of operating assets. And we did them because concerning failures had occurred at PV systems that were installed at this off-taker's properties. And they wanted HelioVolta to assess the risk of similar events occurring at other locations. So first, our inspections helped identify a segment of projects with a high volume of major issues and a few critical issues as well. But things really got interesting when we started to look for a common thread to connect the projects that had problems. So as you can see here, there was one EPC that they worked with that had a much higher number of average issues per project than the others. We also saw issues at projects built by this EPC that simply weren't found at other sites. The wrong equipment was installed that wasn't specified in the drawings. There was consistently poor wire management, and there were systemic cross-mated connector problems. These analytics created a training opportunity for this company. And to be clear, the real problem, the underlying problem for this EPC was extremely rapid expansion and hiring challenges. But looking at the data made them understand that they had to do something about it. So in other words, this was really a teaching moment. So, this really brings us right back to the beginning. Teams need training to prevent downtime, and the best place to focus training efforts is the equipment where nonconformities are observed most frequently. So on this slide, you just see a couple of images that kind of live rent-free in my brain as examples of what not to do and why. Wiring, connectors, these might feel like details, but details matter. And if you're not careful, if you overlook the details, they are going to be your biggest headaches and the cause of your greatest losses down the road. But training is really only half the battle. You also need the right tools to document issues in the field consistently, to conduct robust, independent QA/QC through the construction process, and to generate punch lists from those inspections with the click of the button. You need to build a database of observations from your own fleet. That is how you find the blind spots in your portfolio before they find you. So, what should you do if you want to learn more? First, the data I shared in the first part of today's presentation comes from our PV health report. It has a lot more findings that I didn't even cover, and it's available as a free download on the SolarGrade website at solargrade.io. And then next, the SolarGrade platform can help fast track your field data collection, and it comes with all of the site inspection templates or checklists that HelioVolta's field engineers use for health audits and construction QA/QC. And you can get a demo right on our website, or you can reach out to me directly. And my contact information is right here on this screen. So with that, I'm going to thank you for your time and your attention today. And I'm going to thank Rylan and the Sinovoltaics team for giving me a chance to share the stage.
Wonderful. Super, super interesting. We have a couple questions coming in. I will start fielding these, but if you guys have any questions about the presentation, about the softwares mentioned, please throw them in here. All right, I will start picking some of these out. We'll go to Tori first, since that presentation is still very lucid in our minds. How does HelioVolta's risk severity rating work?
Got it. So basically, risk severity rating comes from a matrix of questions that our team completes when they're in the field. And each question assigns a point value to the issue for things like electrical safety, thermal risks, codes and specs, frequency, and the likelihood of failure. And anyone can actually use this matrix. We publish it. It's available as a mobile-friendly kind of calculator widget right on our website that you can use in the field.
Is this something that HelioVolta, sorry, personal question, is this something that HelioVolta updates and develops actively as you guys are seeing more things coming to the
Totally.
scene?
And we welcome feedback. So if you use this matrix and you get a result that you didn't expect, please tell us. I think it's something that really has to evolve as technology advances. There are new risks. There are new things to keep in mind.
Yeah, interesting. Next question is for me. Hi, Rylan. How is the risk of unpacking the defective modules and repacking the sorted good modules handled? So this is referring to when we apply Selma, the software, to do the analysis of the modules. We are getting transparency into which exact modules are defective. This is all tracked through the serial number of the module itself. So we're seeing a serial number. Next to that, we see what the defect is, critical, major, minor. And then we have to go find it. So this analysis is done at the end of every day. So before the modules are packed up and ready for shipment, they are set aside and we remove them at that time. So they do not get packaged with the rest of the modules. So there's no risk of trying to cut all these straps and unpack modules and risk damaging anything. This is all done before modules are packed up. I hope that answered your question. All right. Got another question for you, Tori. I can mark this as, what goes into a typical HelioVolta health audit? Is it different from QA/QC?
Great question. So first, we work from about a 300-point PV system health checklist for site visits. The specific items vary by project phase, system configuration, typology, and even specific client requirements. It includes visual and thermal inspection, often drone flyovers too. And we also check to see if the system is built to the drawings, codes, and specifications. So with operating assets, we go into that inspection with an expectation of wear and tear. We don't expect a pristine and shining system the way that we expect a recently commissioned site to be. But we also have the benefit of additional data with operating assets that give us a better picture of system health. So we look at production data, component alarm history, and O&M logs because they tell additional part of a project story. And of course, you don't have the benefit of a site history to review with a pre-energized or recently energized system. So there, our QA/QC work is more focused on assessing whether that system is being constructed as intended and as specified.
Got it. Interesting. And I'm going to follow all these with a clarifier. I'm now realizing. Is this specifically for PV sites?
Yeah. So we have another checklist for storage.
Okay, but you do cover PV and storage. Yeah. Just wanted to make sure.
Yeah. And EV chargers.
All right. Okay, we have another one. So this question is for Tori. How does HelioVolta only work does HelioVolta only work in the C&I market? Do you do larger projects as well?
Yep. So the bulk of our work is in the C&I space, but we also support utility scale clients, both on the services side and the software side. When I think about differences, like issues with trackers is what comes to mind first. But generally speaking, though, issues with DC distribution, that's a consistent through line, regardless of market segment. So if you're working in the utility space, everything I said about connector, wire management, and wire termination training still matters, still important.
Yeah, downtime hurts everybody. So
yeah.
All right, Fernando has a comment question. I don't know if you want to read this out. This is directly applicable to you.
Yeah.
Just hear your thoughts, I guess. Yeah.
I can really appreciate the problem of cross-mating connectors for small EPCs that depend on country distributors that sell modules with module brand connectors, but BOS real original MC4 Stably connectors. What do we do? I have requested modules with MC4 connectors and get a variation of the following answers. You're the only one that requests this, or only if you buy a whole container. So first of all, you are absolutely right. This is an industry problem right now. And if I'm going to be honest, I feel like I am part of the problem. I used to work at a module manufacturer, and I distinctly remember sometime in, I want to say 2015, updating the data sheets. So they said MC4 compatible instead of MC4. So I'm sorry. And I would say today, there aren't great solutions, but probably the best one is jumpers to avoid mismatch, or just replacing the OEM connectors.
Got it. Also, David, your fearless leader, is posting some really helpful links in the chat if everyone sees those for your reports and your risk matrix that we've just talked about. So that is super helpful. Also, this can be found on your website. All right, we have another question. Quick question: how long has SolarGrade been around for?
Oh, great question. So our company was started in 2021. So that's kind of like where our software product was first rolled out and started to be developed. But, you know, it really, the idea came much earlier. Our co-founders had long careers in the field as third-party auditors and technical advisors, and they were really frustrated with the tools that were out there for generating reports from the work they did. So SolarGrade started as a tool for lightning fast site visit reports. And now it's become way, way more powerful than that souped up ultra fancy PDF generator that it once was. But it still is that too.
Got it. All right. Next question. At Rylan, all QA companies do module inspections. Can you explain the difference between SELMA and standard sampling? This is one of my favorite topics of all time. So this is a dangerous question to ask because I will go over time, but I'll try and keep it short and sweet. So yes, QA/QC companies typically do sampling at the manufacturer, which is you take a small subset that you hope is statistically significant for the whole, and then you do tests on those modules, and then you extrapolate to understand if you have a bigger risk that could affect the outcome of the project. Usually this is like a 1% or less tested modules being tested, and then it is a binary outcome. So if the modules you test come back and it is above a certain threshold called the AQL level for each category of defect, then you reject the batch. So in the situation where you have a cluster of defects and you sample those defects, you would then need to reject that batch because it's outside of the scope of the contract to ship, which can cause delays and other issues, or just not be representative of the whole. SELMA is a software that runs inline. So it is going through every single module. There's a EL test post-lamination. So once the final layer has been put on the solar panel, an EL image is taken of every single panel. And all of those panels are run through our analysis. So sampling compares less than 1% of modules and predicts how many defects are there. SELMA looks at every single module and tells you exactly how many defects are in the entire batch. Also, last thing, and then we'll jump away because I will talk about this forever, is that for sampling, you are providing an understanding for how many defects theoretically could be present in a batch. And then you're kind of just accepting that they're there. You're more knowledgeable that they could be there, but you're just accepting that they're there. For SELMA, you're doing the analysis, you're figuring out where the defects are, what the defects are, and then you're removing all of those defects. So you know that the defects are gone from your order by the time they get to shipment. So very, very different approaches. Call me crazy, but I feel like 100% transparency is better than less than 1%. So, but I'm biased. All right. We have another question right here. I wanted to ask you if I could have the technical information of the panel from the simulation in Design Builder. Tori, I believe that's you. Are you familiar with Design Builder?
No.
All right, me neither. All right, maybe it's a different software than I think it is.
We'll move on. I'll hazard a guess here and say that when you create a project in SolarGrade, you can automatically import technical information about the equipment from the CEC database. So maybe that helps.
All right, big question mark. If you want to re-ask that question, then we'd be happy to try and answer it again, but as it stands. Okay, a question for me. When you, or to Rylan, when you find defects, do you just send them back to the manufacturer? And how often does this manufacturer get it wrong again when they send it back? So a couple of tweaks here is all of our inspections are done at the manufacturing plant. So the we have no need to send them back to the manufacturer. We can simply be on the manufacturing floor and pull them out in real time. So there's no need to ship modules back and forth from anybody. We are removing all defects before they are shipped for the first time. So it goes along our principles of have as little negative defect as possible, or negative impact. So if we ship things back and forth, that would cause delays. Better to just be on the ground at the manufacturer themselves and remove those defects in real time, so it doesn't cause any delays, and you don't have to worry about shipping multiple modules. So, and then how often does the manufacturer get it wrong again? For all of our processes, we expect that there will be a certain amount of defects, and we require the manufacturer to overproduce to compensate for that predicted amount of defects. So in the scenario where we found 5% defects, for example, for this project, first we're figuring that out in real time. So we're talking to the manufacturer and letting them know that these are what we're finding, and we're going to have to find replacement modules. So they're going to produce more modules than were originally needed for that order to satisfy the requirement of having the best quality modules only being shipped. So I hope that answers your question. We're at the manufacturing floor, so we don't have any use to ship them, but we do that corrective action. All right. Question for Lance. How does georeferencing work in SolarGrade?
So georeferencing works by leveraging the native GPS function of a mobile device. So basically, when you're using the app, you take a photo and it's tapping into, the phone's automatic sensing of the location. But, if you have low service or the location isn't quite right, you're able to move the pin to the precise spot. If you're uploading a photo, you could also use the metadata from that photo to enter the location.
Lovely, lovely. That's a good question, actually. Replacing the OEM connectors does not void the manufacturer warranty? Question.
So yes, it often does void the manufacturer warranty, but in some cases you can actually get approval if proper documentation and procedures are agreed upon. So yes, but also no, you can try to get around that.
We have another question. Does every solar manufacturer allow Sinovoltaics to inspect the order? What's the process for ensuring this can happen? This is a super good question, and it requires a little bit of forethought. So we've inspected over 360 different manufacturers. So I can say with confidence, we have been able to get into every manufacturer that we've set our mind to get into. And the reason that is because we encourage our clients to write in their contract that they are allowed some transparency rights and some data rights for their equipment that's being manufactured. I think it makes sense to everybody that if you're paying for a product, you should be able to see how it gets made. There's no need for a manufacturer to hide that information. So we encourage that our clients write into their contract that they have the right to assign a third-party, unbiased auditing entity to enter their manufacturing plant at the time of their production. In the case of an inspection or in the case of an audit, they can enter before the production happens to qualify that manufacturer. So it's written into the contract, and then at that point, there is almost no pushback at all from manufacturers. Also, at the end of the day, we are ensuring modules of very, very high quality come out of any manufacturer. So while it might seem like it's a slight headache for the manufacturer to go through the process of having our auditors on site and to do the actual inspections, in reality, the result that the buyer is getting is extremely high quality modules. And both us and the manufacturer are playing a role in making sure the best quality equipment is being shipped. So everyone is going to come out of the experience with a very, very good trust in how everything was made and how the process was handled. So we get very, very little pushback from manufacturers at this point. Also, we've been established for a long time, and most manufacturers know who we are and know that we're very professional. So not a lot of pushback. Good question, though. All right, I think another one for me, maybe. Do you have any materials you can send me on the traceability ESG support? Yes, I have a bunch. There is resources on our website, but I can also individually send you some media on that. No worries at all. Or we can just have a meeting directly. Tor, if you find any interesting ones, shout out, but I'm going to keep on going down the line.
All right. So go ahead, Rylan.
Yeah, sorry. Okay, so this question is, can you discuss the value of upstream inspections versus module inspections, glass encapsulant cell factories, opposed to just the module factories? Yes, so there are some companies, some buyers who are interested in having upstream equipment looked at. I think this is becoming more common in batteries as well, where companies are very interested in looking at the integrity of cells of the batteries before they're packaged and containerized. I think it's extremely good for transparency as well, because you understand exactly where things are coming from, what materials are used. You can track that extremely directly. You can have a very high rate of confidence. But I think on the flip side, you will catch a tremendous amount of the errors and defects once the laminate is put down for solar panels specifically. Because if you have a defect in the solar cell, then you will catch it once the entire module is laminated. There is a caveat to that with these specific components themselves. So for glass or encapsulant, things like that, it's extremely important to verify that the correct bill of materials is being used for your module. So glass, encapsulant, connectors, even like the paste for the junction box, it's all specified in your contract what is allowed in the bill of materials. And we often see like a 20% variance between like what's being used and what's allowed to be used, which is wild. It continually blows my mind. But yeah, so verifying that the bill of materials is correct is super, super important. And yeah, but they're both very valuable. They tell you different things, but yeah, if you do the module inspection and then the bill of materials, I think you'll have a really, really good understanding of what's going on with the factory. What else we got? We got 3 minutes to sneak another question in.
Yeah. So I can't make this visible to everyone, but 2 questions around like who can use SolarGrade. So this is a subscription product that can be used by any type of company. We have all types of clients: developers, EPCs, O&M providers, off-takers. We work with some companies that don't even have self-perform teams. They hire subcontractors, and their subcontractors use our software. And then in terms of pricing, there are a few different levels of subscription. So please reach out, and I'm happy to put together a quote for you, Giovanni.
We have 2 more questions I'd like to blitz out. First one is the database for HelioVolta biased towards low quality projects?
So, I think maybe it's fair to say that when the company was first starting out, we really focused on a bunch of root cause analyses, and that might have been a bit biased, but I really don't think so at this point. A lot of our inspections are for, asset owners that really just want to do a quality check on some of their EPCs or O&M providers. It's technical due diligence for acquisitions of projects and portfolios. So I do think it's representative of trends in the CNI market that, in the US specifically.
Yeah, no, it makes sense. Also, if a company's going through the trouble to do active tracking on their projects and do all these fail safes, and they're probably doing all right.
Yeah,
and
that's
they
a
just
great
want that. Yeah. Last one to try and sneak in. Tori, do you use data from different O&M companies using monitoring data to diagnose issues, or do you solely rely on your personal inspections?
Oh, yeah. So if we're doing work for a client, we look at all of those data sets, and especially for things like failure RCA, it's important to see the full picture. In terms of our platform itself, we don't integrate performance data directly into our platform, but that's something we're working on this year.
Cool. We'll look forward to it. And with that, we'll call this to a close. A lot of interesting information. Both Tori and my information is here. Feel free to reach out to schedule meetings with either of us to talk more about any of these topics. We're both kind of enjoy nerding out, so feel free to ask questions, send us emails, and let us know. Otherwise, it's been a pleasure. Thank you, Tori, for speaking, and I hope everybody has a good day.
Yeah, and thank you, everyone, and thank you, Rylan.
Visit Sinovoltaics.com to learn more.